So tonight I want to talk to you a bit about predicting price. It's a problem we've been working on for just over maybe a year and a bit now. Erin and I, who sat at the front here as data scientists, started tackling this problem sort of middle of last year. And I'll tell you about why we started tackling it, some of the things we learned, hopefully some things that will be useful for you guys in your own companies or in your own startups, your own technology. So as I said, I've actually been looking at this problem for quite a while. I had a company before Airbnb that they acquired last year. And now I do a lot of work with payments, trust, risk, growth, particularly. Are these things that setting the right price, having a marketplace that's liquid, is hugely important for. What I want to get out of this talk tonight is actually a few things. The main thing being to actually kind of explore this space we have between an online experience and an offline experience. People are actually having to value real assets that they own. They're having to value what it takes for someone to come into their house. So part of it is a data science problem, an engineering problem of how you actually predict price, and part of it is about how you actually communicate that price, set up that price, and get people set up for success. So just an overview of tonight, I'm going to start off with just a bit about the problem, why we started trying to address this, why does it matter what price you pick. Talk a little bit about the kind of solution that we settled on. A couple of implementations we actually went through. There's a whole bunch of learnings about technology we used to do this stuff. Actually, there's some really interesting things we discovered about how you can actually test price in a marketplace. It's not as simple as just running a straight A/B test. There's a lot of nuance there that we can share. And then a few final thoughts about what predicting price is all about. Okay, so to kick off, what is the problem? Why do we even care about predicting price? Pretty much every company that sells something has to choose how much money to sell that good for. It's existed for centuries, the idea that you have something, you want to sell it, it's basic trade. What's new about Airbnb or things like eBay or these online marketplaces is we aren't the ones who are setting price. We don't determine how much something costs. An average person on the street decides how much their cost. An average host has to pick how much they should charge for their space. So to give you a bit of background to this problem, this is Snow White. At the start of last year, we went through a whole exercise where we storyboarded our whole user experience journey. It was a way, instead of looking at our business from the technology, or from the web design, or from graphic design, or from branding, it was how do our customers see and perceive our brand. Downstairs on the floor, we actually have laid out across the wall, basically a storyboard of the whole Airbnb experience. And on the host side, there's a really interesting moment, which is first setting up your listing. This is the point you've heard about Airbnb, you come, you sign up, and you're hit with this. And this is pretty easy, right? Everyone knows whether they live in a house or a castle. They know if this is their entire place, it's a private room, a shared room. They know how many people it sleeps, they know where they live. Right? These are the easy facts. You get through that, but then you get this. How much do you want to charge? And people, what the fuck? I don't know how much, my place is worth. What is a 2-bedroom in the Mission worth to me or to somebody else? How much should I charge for my place? And what it turns out is that open up your home to a stranger is a rather interesting problem, right? It's this online meeting offline. In places like eBay, that's not really a big thing. It's an offline asset, but you never meet the person. You just get rid of your goods, receive money, and you hope for the best. You get things like Lyft and Uber. Sure, you share 10, 15 minutes in a car together, it's a personal space. But Airbnb, of course, someone might be staying for a month in your home, the most sacred of sort of spaces in your life. And therefore people have no idea how much it's worth. So we set out, we did a whole bunch of interviewing people about how do you pick price? What matters to you when you are trying to determine price? They have a whole bunch of fears, they have questions, some people are already running their own little A/B tests on their own price, trying to figure it out. So what I want to share with you first is some of the key sort of learnings we got from these interviews. The first is this idea of FOMO, this massive fear of missing out. What if I charge too little, I get a ton of bookings, and I realize I could have charged more? That's a huge pain point for people. They're just very worried that they'll get it wrong. They'll realize they could have made an extra $10,000 that year. On the other end of the spectrum, you have this like no bookings. What if I charge too much? I charge $1,000 a night, no one books, I lose out, I make no money. And the next one is this sort of interesting concept, like an endowment effect, basically. Because it's your actual home, it's a place you actually live, the way you value that asset is very different to if you're valuing what a meal is worth in a restaurant. Basically, like, in economics, you have the concept of like willingness to pay and willingness to accept. Like, how much are you willing to pay for a given thing, and how much are you willing to accept for that same thing? And you see a huge spectrum in things like, a book is pretty much equal. Like, I'm willing to pay $10 for that book. I'm willing to sell it back to someone else for $10. Cars, people have a bit more personal attachment. They kind of want more than they would actually go to sell it. But when you get to people's properties, their lives, their place they live, their willingness to accept is way higher than their willingness to pay. I want accommodation, I want cheap budget accommodation. I want a stranger to come into my house, like that is a completely different thing, even though it's the same asset, right? It's a spare room. It's not only for cars, cars, Uber, Lyft, strangers in your place, but like Airbnb, the problem is really compounded. So it comes down to this question, like, what is the additional cost for me to actually open up my home to a stranger? How much more do I think my place is worth than I would pay to go stay at someone else's place? Another interesting concept was this sort of idea of like the greener grass. Like, am I missing something? Okay, I'm making bookings, I'm getting money, that's great, but I look in search, and people who have a higher price are getting more bookings than me, or they're doing better than me, they're getting more, they're doing better. This continual fear that maybe someone else has figured out some trick around pricing that you haven't yet managed to figure out. So those are kind of the main sort of drivers behind the kind of like the personal side. So next I want to share with you a few of the kind of like more marketplace level dynamics we noticed. So in a marketplace, one side is generally always competing. So if you have more supply than you have demand, or more demand than you have supply, the side that is trying to compete for the other side's attention will be competing with itself. So if you have a market where a ton of people want to stay, and you have few hosts, those hosts are living in luxury, right? They can get as many bookings as they like. But as soon as that turns around, and that host starts to feel they're competing with their neighbors, kind of interesting dynamics start to happen. They stop spreading the word. They don't go viral. Like, why would I tell my neighbor about this thing that I think this resource is becoming more scarce? They start behaving weird ways. They set price differently. One of the big things to try and avoid is race to the bottom, right? That you have people competing to get the same number of bookings coming in, and they're very worried that the only way they can compete is to lower their price. If I lower my price, I'll still get bookings. If everyone lowers their price, there's a huge race to the bottom where nobody wins, right? Because the final outcome is that everything costs $0. In which case, as a business, we don't work. Hosts, don't make any extra money. No one's a win. So to counteract this, you always have to find ways in any marketplace to provide the side that's competing a way to add value that isn't by lowering its price. So at Airbnb, for example, recently we launched hospitality. These idea of these 9 standards that hosts could meet in various levels. And there's many reasons for that, but one interesting part is it's a way that hosts now can better themselves. They can prove why they are more valuable than a competing listing in the same market. Same like professional photography. It's a way that hosts can put value in, get more money, without having to lower their price to compete with other people. Does anyone know this picture or what this is depicting? So this is was a phenomenon in 17th century Holland, tulip mania, which is the opposite of a race to the bottom, which is where things become so overvalued that the price just keeps going up and up and up. In the picture you see it's a whole bunch of monkeys. This monkey has a list of all the most valuable tulips in the world. These monkeys are selling them. There's a monkey over here who died and he didn't have enough tulips or had too many tulips or something. But the point is, the opposite of a race to the bottom is that you are continually increasing price, and there comes a point where that is no longer sustainable the other way. So these are kind of the two, the two extremes we have to try and avoid if we're going to start getting involved in pricing things. It's how do we stop people lowering their price to the extreme, how do we stop them? How do we prevent like hyperinflation on the other? So pricing, we kind of thought, great, we'll just write some super clever algorithm, we'll go deploy it, and make a ton of money, and everyone will be happy. But it turns out it's not quite that easy. People have these huge preconceptions about value. Even if you told them what you think their place could go for, they don't believe it. They believe their place is worth more. You build a perfect algorithm, you don't want to come back in 3 weeks' time and find that everything in New York costs $1, or everything in London costs $1,000. So a lot of thought went into it. So what do we actually go do? Like, how do we go try and solve this problem? The first thing we did was like, let's just suggest a starting price. When you sign up, let's figure out how to suggest to you where you should go. Get you in the game, get you feeling confident, get you set up, get you receiving bookings. Once you have that, just tell you when to change it. If the season's changed, if big events are coming up, make sure you don't ever start to wonder if you could be doing better. Like, we're continually helping you set the right price. So the main sort of approach we took was just to automate what hosts were already doing, which is they'd sign up, open up a new tab, try and find similar looking listings to themselves, see how much money they kind of thought they were making, and pick that as a starting point. We can obviously do that far more intelligently, we can do it far more quickly and far more reliably for people. So to get the baseline, there's basically three axes, if you like, that we were trying to graph against. Location, in our first iteration, was just a straightforward expanding radius. We want to obviously see what people close in the same neighborhood are going for the same city. Recency, so we don't want to know what 2 years ago it cost to book in New York, we want to know what it costs right now. And then likeness. And for likeness, we basically looked at a regression on what is the guest's willingness to pay. What are the things that are most highly correlated with what a guest is willing to pay for? And 4 key things came out. The room type, obviously, whether it's a private room, a shared room, a whole apartment. The property type, is it a castle? Is it an igloo? Is it just an apartment? Is it a terrace? Like, is it an apartment block? The number of reviews. It's actually possible to almost put a dollar value on what a review gets you in a marketplace. The difference between no reviews, 1 review, 3 reviews, 10 reviews is actually huge. What's interesting is we could bucket a lot of these things. The difference between 0 and 1 reviews is far more pronounced than the difference between 10 reviews and 11 reviews. So it's not just straight linear, linear correlation. It's like a kind of stepwise function. Same with capacity. Interesting one on capacity is you can always sleep fewer people than the total capacity could indicate. But if it sleeps 1 or 2 people, that's kind of one thing. 10 or more, completely different thing. So once we had that baseline price, basically we try and find the most recent bookings at very similar listings in the same location and see what their kind of market rate was. We then looked at overlaying seasonality. So how do we know when to tell you to change your price? And there were kind of 3 approaches we looked at here. First was our own SDI, supply demand index. So we'd look at when people were doing more searches for a given place, figure out there was probably some higher demand, you could increase your price for higher demand. When demand dries up, you should lower your price, right? The next one was actually looking at hotels and flights. Really interesting, hotels, well, if people are booking flights in great numbers, they're probably traveling. If you know where they're going to, you can figure out that there's increased demand in that place. The third one we looked at was actually an unexpected one, which was just looking at temperature. It's correlated with almost everything ever, but it's also correlated with price. In the south of France, the hotter it gets, the more people are traveling. In Whistler, the colder it gets, the more people are traveling. So as a real worst case fallback, you can just look at a temperature curve in a market and be like, well, if it's getting hotter, if it's a market positively correlated, if it's getting hotter, prices go up. If it's inversely correlated, prices are getting colder. If it's getting colder, prices should go down. So what we ended up with, before I go into the kind of technical details about what actually took place, is obviously we had this ability now when you signed up, we could suggest you a price. In our actual new managed listing sign-up flow, we could suggest things. All of our new mobile apps, which we relaunched last week, yep. But also previously, maybe a month or 2 ago, we actually allowed you to sign up as a host on mobile, have price suggestions. What's interesting on mobile in particular is like that's definitely a place you want doing research and opening new tabs and trying to look at price. Like for that sign-up experience to be super smooth, price is one of the biggest friction points that we had to like get out of the way of getting you signed up. And then this is what the calendar screen would look like. Here we're suggesting for May of this year a price, we're suggesting a weekend price that's slightly lower. And you see the price recommendations for the actual like baseline stuff down below. I'm not going to talk too much about this one tonight. This is actually an interesting experiment we ran around how you can actually convince someone that the price you're suggesting is right. We did a whole bunch of work on like anchoring people around certain prices. Everything from like super crude color scales where like people don't want to go red, they like staying green. Or it's like shifting the whole thing $10 higher so that they go lower and therefore actually end up at the right place anyway. But there's a whole, I could talk for hours about the whole like psychology of how we try to get people to adjust or take a price that actually fit with reality. Okay, a little bit now about like what we actually built, the technology and the kind of stack we have behind it. So this was our first implementation. Monorail is our Rails app that is basically most of our front-end application. Ganesh, don't need to worry about, is our customer service application. There's then the auto pricing client, which is straightforward Ruby gem. It was built from Typhus. It just makes HTTP requests to a series of auto pricing nodes. Each node was running Ruby, something called Grape, which is a DSL for writing APIs. Each one had a small Redis and REST queue set up for a bit of like light background processing. And then it would pull data directly from one of our production slaves. We used Zookeeper for like client discovery, ephemeral nodes, and when they timed out, the node was dead. And it was kind of how we did services here for a while. There was a separate RDS instance. There's one on Amazon that would house all the predictions, and that would be dumped into Hive every night if we wanted to do analytics on it. And this kind of worked. Like there was some logic in Ruby that would pull out some details of similar hostings, do a MySQL, like straightforward expanding radius, make some comparisons, spit back a price, and record the price in the instance. But there were a couple of problems with this approach that we found. The first was around location. So let's suppose we're trying to find the best price for this blue listing here in the middle, right? So we do a straightforward, like everyone does it, like a bounding box with a circle inside it in MySQL, and we get these two listings. And we're like, great, those are the similar listings. We'll compare it to and look at how much they're being booked for right now. But then you go and look at like actual geography in the real world. Turns out it's a bit of a shit. And you get like a river going through your lovely circle. And what you find that in, say, London, this is the Thames, but this is like Chelsea, Knightsbridge, and this is wonderful, and this is like Tower Hamlets. And like up here, you're sitting in cafes, drinking Chardonnay, and down here, you're being stabbed and knifed. It's terrible, right? And obviously, people are willing to pay more money to be up here than they are willing to pay money to be down here. Like, that's a given. So like, that was one problem we had. Like, in dense markets where you have highways, roads, rivers going through cities, and a radius makes it very hard to actually compare lightness for price, given people's propensity to pay for like specific neighborhoods in a city. The second thing we noticed is people don't change their price daily, right? We could build the most powerful algorithm in the world that could compute prices to the nanosecond to like sub-cent values. Nobody cares. Like, people change their price like once every couple of weeks. An example of this actually is something called like a menu cost, right? Like in markets where you have hyperinflation or hyperdeflation, or even in Bitcoins, like right now, which is super crazy high inflation, there's actually a cost for people to go change their price, or for a restaurant to reprint their menus. And inflation has to be above a certain point for them to even bother reprinting a ton of menus. And hosts have the same thing. They're not going to like every day log in to adjust their price by a few dollars here and there. That's just too much effort. They want to get it set up, they want to leave it alone. So the two things were like location was not accurate enough, and people didn't need real time up to the second prices. So this led to our second and current implementation. So what we've done here is we've actually moved all of the prediction lifting out of like the request response cycle and put it in our ETL pipeline. So Kronos, which is a technology we open sourced recently, built on top of Mesos now, runs a series of jobs that actually take the previous day's production dumps, predict the price for every listing in that dump, and put it on S3. From S3, we then wrote a new service in JRuby using H2, which we'll talk about in a minute, where basically once Kronos completes the updating job, it sends a notification to the production servers to say, hey, there's a new batch ready to be processed, and they each go and read off S3 a compressed CSV basically and load it into their memory. We then use Synapse now, which a tech talk a couple of weeks ago Martin and Igor gave on SmartStack. This is basically where we run HA proxy on each individual node that's dynamically configured by a zookeeper to do service discovery and recognition. I'll show you that in a second, which makes clients coming in and out of the cluster super easy. And then again, monorail and Ganesh on top. So why put it in Hive? A couple of reasons. So prices don't change. We're able to access a ton of richer data than we were in the request response cycle. So we can look at things like all of our request logs for the previous year. We can see how many times a given listing has been viewed, let alone booked. We can see how it compares when it was in search, where it was in search compared to other listings in search. This allows us to get things like uniqueness. It's very hard to put a price on the color of your carpet. We can't infer that. That's not metadata we can read from your description. But it might well be there's something highly unique about your listing that means it is worth thousands of dollars a night, which we can get at if a lot of people are looking at it or initiating contact. There's obviously some connection between the price they saw and their willingness to go and investigate that listing. So H2 is an in-memory relational database. It's written in Java. Basically, it's like sort of MySQL, but you can run it inside your process or as a separate TCP process on your box. And with this, we basically are able to preload, take the pre-computed data, load it very fast into memory on EC2 instance, and then have it available effectively like an intelligently warmed cache. If it's a request for the price for a listing we already have, it's just a straight primary key lookup and the response goes back. If it's not, then we can do some stuff I'll show in a minute where we can still make it highly performant. So I just want to quickly show you a few of those things. If my screen will look at it. Cool. So this is just Kronos. This is our job scheduler for ETL pipeline. We have there's obviously got 6 jobs in the auto pricing queue. They're dependent on each other. They run a Hive script. They succeed generally. Sometimes they fail. And they basically process on HDFS a whole bunch of stuff. The final one here, servers, is the one that updates servers with the latest output. So this is an example of H2. This is configuring it. It's exactly like SQL. You're just creating a memory table if it doesn't exist called hostings, usual primary keys, standard data types, creating indexes as you would on MySQL. And then in Active Record, if that's what you want to use, you can write straight SQL to it. We're using just the JDBC JRuby drivers to load that in-memory database. You can pass it a whole bunch of configuration options, actually usually word about locking and table locking, database locking, or you don't want any locking, concurrency, and the usual things. And then this is an example of basically the Hive query that is powering auto pricing. So you see just down here where we start bucketing things based on what they look like. We then run a whole series of weights based on proximity and such, and output the results. So just an example quickly of what, just to see Synapse in action and how the process reloads. It's pretty cool. So if I tail this is one of the production boxes, just tail the log. You can see it making a whole ton of predictions in 5 milliseconds, 3 milliseconds. It's also, you can kind of make out it getting ping requests from every other Synapse node that's connected to auto pricing. And you can see it making a ton slash health checks from the local synapse that's running. So now if I just restart auto pricing, we'll see it go away, and in a couple of minutes we'll see it start booting back up again. So right now, every other node in our production cluster that's talking to this node will no longer receive a health check, take it out of rotation in its local HA proxy, and just carry on serving traffic to the others. The application on top of that HA proxy has no idea which node is available at any one time. It just talks to the local host. So it's coming back up, creating the various in-memory tables if they don't exist. Like there's just a global mutex lock to lock the world, and now we're pulling off S3 the various data types we need. And it'll start crunching through them and come back into rotation once the health check reports that everything's back in a good state. Cool. The other great thing we got access to is a product we launched over a year ago now, neighborhoods. So if you go to airbnb.com/locations, you see these wonderfully rich guides to neighborhoods all over the world. But what's interesting about this data is actually behind the scenes we have incredibly rich polygon mappings around every neighborhood in the world. Well, not every one, right? Like most of them. We have a cartographer who spends a lot of time very carefully defining boundaries around individual neighborhoods. And this data is all available offline for processing. So we can get very sophisticated, very granular neighborhood data that can solve all of those expanding radius MySQL problems. We're now able to bucket things by real, actual neighborhoods that people care about. But there's still a problem, which is you take a database dump today of every listing we have in production. Overnight, we compute prices for all of them, and tomorrow, they're ready to be served. The problem is, what do you do with listings that get created tomorrow? They don't have a way to have a price computed. We didn't want to reinvent the whole previous version we had just for those listings on the one-off case. So we tried to settle on some halfway solution. And we implemented, or just kind of discovered, I guess, no, I heard it before, this concept of geohashing. And a geohash is a hierarchical spatial data structure. It offers arbitrary precision, so basically you are taking a lat long and turning it into a text string. And the longer the string gets, the more accurate your representation, and the shorter the string, the less accurate. And if two strings look the same, if they start with the same letters and numbers, then they're very likely to be in the same location. For an XKCD explanation, try and make sense of that. But basically what you do is you take the whole globe, and you split it into quadrants, and you give each one a letter. And then inside each one, you give you break it down to a series of buckets again and give those a letter. And then you do the same thing again, around a particular neighborhood in New York, and you give each one a letter. So effectively, we're able to turn a polygon into a series of text representation boxes. It's not perfectly accurate, but it's pretty good. And the key thing that's interesting about these text strings is obviously SQL databases are able to do these kind of lookups. An indexed 8-character string can be an extremely fast lookup for a SQL database. So new listings, when we get a lat long, we geohash them and then try and compare them against other geohashes of a similar length that we have to identify similar listings in the same neighborhood without having to do too much heavy listening behind the scenes. So, kind of the final chunk I want to share with you is kind of some of the stuff we tested, what actually worked, what didn't, and more importantly, actually, how do you test something like this? It's a very nuanced thing, as we found, to test. So, a kind of problem with the marketplace that we find is that you have supply and demand, and for each of those, you can have an experiment where one is in the control and one is in the treatment, right? you could run a test where for every guest coming to the site, some are put in a control group, some are put in a treatment group, you run an A/B test, everyone's happy. Same on the demand side, you sign up, you see one version, you see another version. The problem is it's extremely hard to isolate both sides of the marketplace from the effects of a test on the other side. So in this case, for example, if we get some hosts to change their price, that fundamentally alters the makeup of the marketplace. Like the average price of that market is now not the same. And therefore, even guests who are in the control group, because we want to see, does it impact conversion? Do we get more bookings out of this? These people are actually affected by the fact that these people over here have changed their price. And it's very hard to isolate this group of people from any changes you make up here. And similarly, even the ones that are in the treatment group that did see it, now see something different because these people haven't changed their price. So if you take, for an assumption that people want to book the lowest priced place at the highest value point, if you're artificially increasing the price of some people and not others, these people are going to get booked before these do. Therefore, when these are left, you've got a very different experiment than you started out with. Does that make sense? Yeah, cool. And it happens the other way too. Like, the experiments you do with hosts, you get some of them to change their price and not others. You're now impacting the control of the supply test. And you're kind of stuck with two choices, right? On the one hand, you accept that there is just a link between the two sides of your experiment, and you just got to live with that. The thing you kind of can't do is have this host have two prices. You can't say some guests are going to book at the low one and some at the high one. Like, they don't care. They're just like, what? I just want my price. Like, why do you make me have two prices? Or you try and fudge it where we pay the difference or something, and try and hope the two guests and the host never figure out that they had different prices. But that's also never going to happen because everyone communicates. So it's like you can't make a guest see both lower and higher prices because the host on the other side is the one that has to actually deal with that request. So one solution that we've tried a few times is to do like per market tests. The chance that a guest is booking both London and New York at the same time are very rare. So we can actually run the experiment in London, but not in Paris. It has its own problems because you're assuming that London and Paris could be roughly analogous markets with similar characteristics. But at least that way you can have a full test inside one market and compare it to another. The other thing, like the whole causation, correlation nightmare, is that causality is super hard with suggestions. I'm just suggesting you do something. I'm not even sure you even did it. I'm just suggesting you go do something. It's very hard to prove a bunch of stuff. Like, often what happens is we suggest to you a price, you'd see the price, we know you saw it, you choose a price that was radically different, and then a month later you'd come back and you'd take a price that was $10 lower than what we'd suggested to you a month ago. We know you had no bookings, but it's very hard to say, well, was it because we showed you that price that you then changed it, or would you have changed it anyway? Or conversely, would you have already picked the right price had we not even suggested it to you? There's a big question on how do you start a new market. Like in this approach, we are relying on the fact that there is some liquidity in the market already that we can index against. We can see what the going rate in New York is. But if in a brand new market, say in Asia or something, it's very hard for us to say what the price of an Airbnb should be. Which gets to a much more fundamental question of, how does Airbnb or how does Uber or Lyft want to compare to taxis or hotels? It's an open question. And finally, there's a whole problem with confirmation bias. The more people do something, the more times it works out for them, the less likely they are to go try something completely radically new. So for a new host, yeah, we can suggest changing a price. But for an existing host, there's this problem that they're even more reluctant to go change a price. Or if they do change their price and it doesn't work out, they're even less likely to come back and try our price again. Just a few in my final couple of slides. I just want to share a few of the outcomes we actually, material outcomes we got. One, this is just a quick graph on the effect of over-underpricing on some listings. And basically, you see if they are at our price, they have the highest conversion rate. Interestingly, if you start charging way lower than the average, you don't get many bookings, and if you obviously charge way more than we recommend, you don't make as many bookings. An interesting attribute here, actually, on the guest side, which I haven't talked about, is how guests perceive price. When people see 5 what they perceive to be identically valued listings, say, they're all 2 bedrooms, they're all in the mission, they all look great. If one's $10, one's $100, and one's $1,000, it's a very disconcerting sense that you don't, like, price is a great proxy for value. And if the price is all over the place, it's very hard for people to figure out what anything's worth. So what's more interesting, on the guest side, we also saw is that as prices become more similar between similar types of listings, not identical, but similar, guests have more confidence that, like, okay, that is the fair price for, like, what I'm getting. People who took our price, you know, who choose our price generally get sort of 3 times the number of reviews. Obviously, not everybody takes it, right? Some people believe they know better, and they get like a ton more increase. You know, being at a competitive price is advantageous. So, just a few final thoughts for questions. Real people are annoyingly unpredictable. If it were only possible to have everyone just do what the computer said, we'd all be fantastically wealthy. But they won't. What's interesting, markets as well, they also have this annoying habit, this is why we get like VCs making a ton of money, no offense to any VCs, is because they're unpredictable. Like they're paying a risk, they're paying a price for a high risk that could turn out to be a great reward. But what's the flip side of that is you only actually have to be as accurate as people's tolerance for change. If people don't care about the difference between $1 and $5, you don't need to build an algorithm that can tell you the difference between $1 and $5. You only need to be as accurate as their willingness to like tolerate change. Secondly, something that, you know, we're starting to get into is like we actually have a ton of data around the company, like neighborhoods, that had never really occurred to us. Oh, that's a cool like guest-focused project. Oh, actually, they've mapped every single neighborhood in our top like 100 markets. Great place to look. It's also interesting to note that you can offload a whole ton of heavy lifting from your request response cycle to like Hadoop and get it back into production. It's a well-versed path. But for many startups, like you end up with this place where like rescue is just doing everything you could ever like throw at it, and eventually, sadly, it doesn't scale, as we found out.